Welcome back to Stationeers. So today we're going to first of all amend our furnace design a little bit. Yes, people were saying they were just saying this regulator, it just isn't needed and it's more dangerous with it because there's a section of pipe. So let's first of all just take that out and then we'll see how well this works without it. So there is that regulator, and I just want to get rid of these for now for a second. And we should need to end the program because it already uses a bit of memory, and that will do fine. And we also have some spare pipe on us, so I just want to grab that regulator. Okay, and I will leave that cable just in case I want to put it back later. We'll see. This will also let us increase this thing up to 300 kPa. So let's just put that in there. And you'll probably see this rise now. Yeah, off it starts going. We're just going to set this to purge mode just to get rid of the excess in the line. So that's going to start dropping down again. And then we just need to quickly check out what is in there. So world, pipe network, there is nothing in there at all. Good. Okay, so everything should be set up. Ready to go. And then I just want to put the iron sheets back. So let's just grab everything and let's see if we can finish up. There we go. All right, so everything's about the way it was, and in there is well, it's actually just draining away. That's going to be fine, and I've got there before the sun came up. What we're going to do is just amend the program so that it tries to pressurize this thing to 300 kPa, not 100. That would take us all the way up to, and now what I'm going to do here is define pressure limit 300. Okay, and then wherever I've put 100 down here, I've done it a couple of times. There it is. Yeah, so I'm just going to put pressure limit. Oops, pressure limit. And same thing there. Just so whenever I want to actually do this in future, I just need to amend that one value at the top and things will change to the new limit. Let's export that. That seems to be okay. The controller is nice and green there, and then this is pretty much depressurized. So let's close that. Let's just double check what is in this furnace. So H2 and O2, and that is off. So what I wanted to really test here is that mixer. People keep telling me it is like a pump, but it doesn't have any kind of attributes like a pump. So what we're going to need to just test is, you know, can it pressurize up to a higher value than the outside, you know, the pressure of the outside pipe. Because if the outside pipe is lower than 300 and it's just a valve, whoop, no, there's a hole in the roof. I could have just gone through the roof. Then I wouldn't necessarily expect it to prime properly, but no, we have more available anyway, so that's going to be okay, even if it does act like a valve. Let's start this up, and let's see if it pressurizes. So 300 is set. This thing should be starting to increase, and good. And let's see if this is actually any good. Well, I've got to wait. It's not very fast, is it? In fact, that's terrible by comparison. Huh. Yeah, so thanks very much for the suggestion. And that's okay, I guess. You see, everything's on there, but that's far too slow. I mean, come on, honestly. Yeah, I mean, yeah, that's too slow. So instead, I'm going to put that pressure regulator back, and we're going to instead, well, let's just get rid of this again. And I'm going to set the pressure regulator to 300 instead of 150, as it's sort of backstop or safety feature, if you like, and that will let us sort this out. So first of all, I'm going to turn the system off, and then we're just going to purge, I think. Get everything out of the system so we don't have anything remaining. It'll all go back through the filters again, so that will be fine. And then what we're just going to do is pull that pipework back out again. It's worthwhile us at least checking this. And people are probably going to say, oh, you did it wrong, but it looks fine to me. I'm just saying. So let's up this to 350 and then just bring it back down again. So let's just bring it back to, I don't know, what should we say? Yeah, let's bring it all the way down to like 305. Okay, so that'll give us a kind of sort of nice little margin for error. And put this back here. There we go. And let's see the behavior now. So let's bring that up. And 1 and 2. 3 and 4. Okay. All right, so then we should be ready to go again. Are you, yeah, you're nearly drained. So let's put it into activate mode and let's see if that's actually any better. 2.5. Okay, so was it me? That's terrible as well. It's probably because there was no build-up then. It's probably because there's no build-up in that pipe behind it. So it isn't terribly fast because that pipe had a huge amount of gas in it. And we don't really have that anymore. So, yeah, maybe it's that. Because that's pretty slow as well. To get that to go any further, what we've got up here, we have, if you remember, let's just take this back out again. We have 2 regulators. Okay, and they will only provide gas at a certain speed. So we're going to do a test here as well. We're going to remove these. And that will certainly make it available to this gas mixer. And we'll see whether this actually helps. So let's just remove both of you. And hopefully we don't get any kind of explosions. But no explosions today, please. That will be very, very nice. And let's just set these together. So now we have a large supply of gas behind this thing. And that means we should have a large supply of gas available to this. That's much, much faster. Okay, so those pressure regulators was just limiting the throughput, which is what you'd expect, that they were there as a safety feature. And this thing is going to come up to the right kind of level. So I guess we could also do another test and remove that regulator and get everything together. And let's see how well the mixer acts on its own. It's a much simpler setup if that's the case. So I'm happy to have that happen. And you are coming up to the right pressure anyway, so let's wait for this to actually finish, because I'm going to want to just ignite this thing to test out whether this reagent is INVAR. And you can't really do any sort of tests with it. It did come through the recycler, so I would like to test it out. Let's just turn you back off again, because we're about to turn this thing on to full. So the furnace should be pretty hot when this thing goes live. Okay, so it's now on to activate, which means this, we can turn this handle off in code as well, which means this thing can be activated this way. Now, if this is right, and I've got everything right, this should go up to INVAR-like temperatures, not steel-like temperatures. So up it goes, and yep, it's going to the right sort of area, the right sort of temperature. Let's see what happens. Whoa, that's white. And yep, it's going to process into steel and INVAR and pull mold. And what comes out? No. Okay, so it's still steel and INVAR. We know that much, but we also know that it is, well, effectively still not separated. And when there is steel and INVAR, what I don't know is how to separate it, because they're both alloys. One's an alloy of iron and coal, basically, iron and carbon, and the other one's an alloy of INVAR. Which is, again, iron and... oh, did I go out through the... yeah, okay. Never mind. Yeah, so how do we actually separate these things? Or can we even separate these things? If I just grab you, will you separate into 2 stacks? Let's just get that shoot out there, and I'll stop my mobile from actually coming out. Let's see if the recycling system can actually separate this even further. So we want it into one particular material. We don't want any other materials in there. So let's see what happens if we drop that in. Were you going to come out in 2 stacks or just 1? Are you going to come out at all? So that's 1 stack. So that can't separate this thing. How about you? Reagent mix 9. Okay. Do I not get any more? Okay, well, let's put the reagent mix 9 through and let's see what this says. Are you hot enough, though? Because we have activated this thing. That is just steel. Okay. We're getting somewhere. We've got just steel. Alright. Can we get just Invar out of this thing? Where's my Invar gone? Because I definitely put 2 lots in here. There's no iron. And I can't see any contents of this thing. Are you in that last remaining chute? No. So, I think there's bugs. I definitely think there's bugs with this thing. It doesn't seem to output things all the time, and also what I don't see is any kind of control on this to stop it from outputting until we get to a certain amount. People were saying, well, why can't you have this just output only... Oh, hang on, wait a second. What? That's just iron. Okay. No idea when that appeared, but that is not the that's not the Invar that we actually wanted. How about, is there anything actually inside this thing? What if I actually take it apart? Oh, with an angle grinder. Oh, yeah, there is something in there. Looks right there, but I need to keep deconstructing this thing. Okay, continue construction. I don't want to continue construction. I want to deconstruct it. Can I actually get that any further? Deconstruct with a crowbar? Okay. So, we've got 2 different reagent mixes, and there's some kind of bug going on there. It's not outputting both of them, or it's keeping it in there. So maybe we have to programmatically control it. I'm not sure. Regardless, this thing is now too cold. Yeah, it's far too cold. So we're going to need to purge that, put it back through, and then reactivate it. So let's just bring that up. And this should be the Invar. Doesn't tell me what it is. And if you stack it together with the other things, it merges them together again. You don't end up with one or the other. So I can't use this to say, grab another stack and end up with just Invar. It does seem to generally mix things, which is good in one way, but not what you normally expect from the other behavior in the game, which is like if you get 2 different colors of things and you stack them, then they become the same thing. So yeah, let's just get rid of you. You are gone. And while that's gone, let's go and test removing this. So we can bring all the pressure regulators out of here. And then we're going to add a pipework back in. And now we're just down to a mixer, which means we no longer need that memory and everything else would be nice if that's the case. So, another pressure regulator gone. Good. And where's my tablet? Is there anything in this pipe now? There shouldn't be, but there is. Probably because it was behind the regulator originally, yeah, and now it's not. But that should be, yeah, that should be evacuating, that's fine. It's just because it was in this one section of pipe here, and we're going to get rid of that. So, 770, so we've got 1.9 kilomoles and 3.3 kilomoles, plenty of source materials, and let's give this a go. So, let's just put this away, you away, and let's just clean this area up just while this is going on. There we go. Alright, so, ready to go again. 91. Oh, hang on. That's not good. That looks like it's combusting. Yeah, that's combusting. You can tell because its pressure is fluctuating. Now, that's okay because it should keep getting evacuated in the system, but I want to make sure it stops. So, there we go. Everything's dropping in sort of pressure. Its temperature's too high. It just keeps on combusting. Let's keep on burning, basically. So that's going to go away. Everything else is still okay. And it's dropping to 10 kPa. Okay, so I'm going to wait until it actually decides it can finally get rid of all of this. There's very, very little other stuff in here, so it should drop really quite quickly and shouldn't really combust, but it is. Even though it's a tiny, tiny amount. There we go, my amends to the furnace have finally stopped causing the problem. Basically, the furnace was hot, and as soon as I replaced the pipe, it then sent in more available fuel and just kept things going, even when it was trying to evacuate the furnace. So just be aware when you're actually modifying things that that can occur. And now we should be able to put it into activate mode again, and that should start. Yep, so this is going to go up to 300, and that's going up quite quickly without all the regulators in the way. So yeah, my bad. Let's wait for this to get to 300, and let's see if we get Invar back. I want this Invar back, even though there's like 3 in it. It's still worthwhile. And there it goes. It stopped at 318. Even though this is at 300, so you might want to think about just maybe dropping this a little bit. So let's activate this thing, and it should go very bright. There we go. And we should be able to put this in. And let's see what we've got in here. And we'll produce 3 Invar. Yeah, look at that, Invar. Oh, so nice, furnace. Okay, and we can leave this basically in the off state now, and everything is pretty good. So yeah, that is simpler, easier to get going, and now I can put the cladding back and everything else can be sorted. So you can go away, and we can simplify the program a little bit while we're at it. So let me just remove that, and yeah, that batch writer's now like, wait, what pressure regulators? What are you doing? So yeah, let me just amend this program then. So let's take a look at that. Is that going to be a simple enough change? It just needs me to remove any lines or anything to do with the regulator memory, because that isn't needed anymore. So in here, regulator memory, we can change that line. Regulator memory, change that line and that line. And then regulator memory down here. And that's pretty good. And we also don't need to actually read that in anymore. So, right, in fact, connect it, I should say. So, regulator memory is D3. And is there anything in here? Regulators on. Don't need that. And I think that's all okay now. Yeah, I don't think there's anything else. Let's just see if it breaks now. Export. And then we can simplify this just by grabbing these chips back. And of course we can simplify the wiring as well, but that's not too much of a problem. There we go. Let's get that back in there. And we're done. So yeah, the cabling has to be neatened up, but other than that, we can leave it there for future expansion if we want to control other things. So that will do for now. Good. So I'm happy with that. Hopefully everyone else is. This program can be made a little bit less as well. We got a few people with some modifications to it to make it shorter, but I'm happy with it for the moment, and we're good to go with the furnace. So the recycler works-ish, and that's something that is going to be interesting. I wonder if those two... let's actually put it back together, and I'll put it back together off camera so that we can actually see that. What I'm going to do is look at the reagent mixes. I want to see... I want to see basically what the reagent hash is, which is sort of an indicator of what that item is behind the scenes. Even though it says the same name for us, it could mean other. It could actually be more than one thing behind the scenes. So I'm going to put this back together, and back in a second. Now, to separate items from each other, we should be able to use something as simple as a chute bin. You'll see we've got a chute bin here. It's not got any pipework or chute work connected to it. It's just got a slot that we can read. And to read it, we can't just point our tablet. Where's my tablet? There it is. We can't just point our tablet at it because it's going to read the prefab hash, which is the prefab hash, I think, of this device. So, yeah. Instead, we're going to use a slot reader. And if you set that to look at either the input or the occupant hash, either of those should get you what you want. In this case, this ends in 434. Now, if I go and get this all lead and swap it, you'll see it now ends in something else, 170. The problem is that, unfortunately, reagent hash, and let's just drop that for a second. So, reagent mix, the 3 one is 434, and the 5 one is also 434. I have no way of telling the difference programmatically, so I can't just sort them. I would love to be able to, I can't. So all I'm going to have to do is, if I do put a sorter after this thing, I'm going to have to sort out everything apart from this, everything apart from this prefab hash can go one way, and you can sort can sort ores into one bin and reagent mix into another, but that's not terribly useful because, to be honest, I want to put them all through the furnace anyway, so I'm not going to bother with a sorter. I was going to do, but if I can't separate these things to say, what I'm really looking for is something invar, because if it's invar, it needs to be at a different temperature. And that's a bit problematic then, because I have no way of programmatically doing it. If anyone knows, or indeed any way to read these whatsoever, I would appreciate it. I can't read them with anything that I can find out. I've looked through the other slots here. They're all, so for example, if we just have a look here with a screwdriver, you'll see we can look at prefab hash, and that'll just, that's no good. That's occupied, sorry. Occupant hash, that's 434 as well. Max quantity is 50. Damage, no. Class is 10. Class is 10 for both of those things. So that doesn't help either. And we're back to 434 again. So yeah, there's nothing in there that I can actually do anything with. And I did also try it with other kind of blocks. If you print off a vending machine, this is another sort of block that we haven't really used yet, but you can pop this down, and it's electronic storage. So if you haven't used it before, like one of these, but there's 100 slots in it, and you can read things on that. But that gives you the same information, I think. Let's just double check. I need to read something else. So centrifuge. I need the vending machine. I think I passed that. There it is, vending machine. So it has storage slots, and you can read those. And then if you read, let me just grab you, pop you inside. Turn you on. There we go. And now we should be able to read the various different things. So damage, class, quantity, occupied, and that leads pretty much the same thing, unfortunately. So yeah, there's not much I can actually do here. I wish I could. But yeah, the vending machine will become useful just to sort of get lots of stuff into lots of storage. But for now, that's fine. Hand drill, yeah. Let's get rid of you. Okay, so not much I can do. I wish I could. So what I thought I'd do with the rest of the episode, if we can't do anything with that, I'd like easier control in this computer program of the pressure. So what I'm going to do, now that we've freed a pin on the circuit, because we no longer need pressure regulators, remember, you are actually still high, so let's purge. We now have a spare pin, so one of these is called pressure regulators. Output pump regulator, it's that one, isn't it? So yeah, let's just change that one to be something else. For that, we're going to basically pull this off the wall to get the right thing. And we are going to put another switch in. Did I get another logic switch? I think I did. I've got one printed. We're going to have a switchable pressure. And we only need two pressures, remember. We need 100 or 300. And you could use a gauge of some kind. Oh, I printed off 5 switches, never mind. You could use a gauge of some kind. I'm not going to bother. I think I want this to be a... Well, let's have a look. Button, no. I guess we can make it a lever. Or a switch. A lever's more explicit. It looks... it's easy to tell when a lever is in one position or another. And let's just get that sorted as well. So you can get connected. So can you. Okay. And then I'm going to need to rename this thing. There's my renaming tool. And we're going to call this pressure lever. Okay. Pressure lever it is. And then we're going to set this pin to the pressure lever. So in here, pressure lever, there it is. And then we know what it is because it's the one that's missing from in here now. So if we just grab that up at the top, and someone did say I can change this so that it's not transparent at all. Kind of. I already had it in its non-transparent mode. Unfortunately, it still shows partially through. So thank you for the commenter, but it's still not great. I want this to be completely opaque, if at all possible. Anyway, alias pressure lever is D3, and we're going to want to read that into something. So let's just say alias. Ooh, actually, I already have pressure. Oh, that's it's a pressure limit I want, isn't it? Yeah, I'm reading the actual pressure up here, but I want to read the pressure lever state. Maybe. Pressure... high pressure? Let's call it high pressure. And let's just use another syntax I'm probably going to end up using. High pressure. So we know it's an actual register and not a device. And that is something that other people did tell me. I used to use in Season 2 and I forgot about it. So yeah, it just lets me identify what that is. So then what we're going to need to do is, once for each of the loop, we're going to read the state of that, that pressure lever. And nothing after that point. So we want to load the well, in fact, no, we need to branch. We need to basically set it to one of two different values. If that pressure lever is off, we want it to store 100, and if it's on, we want it to store 300. So that should be a relatively simple bit of logic. For this, we're going to use a simple bit of logic. We're just going to say branch relative if less than. So if high pressure is less than 1, we're going to jump forward 2. Okay, sorry, we'll jump forward 3. Okay, so let's just then set the pressure limit to 100. Then we're going to say jump to skip high. And then we're going to basically say move pressure limit 300. And then we are going to basically say skip high. Okay, so if it's switches off, we're going to set the pressure limit to 100. Then we're going to jump over the next instruction. And if it is 1, it's high, it's going to skip forwards onto this line, set it to 300. And then that is, that's going to work just fine, I think. Yeah, that'll be fine. So let's just do that. And what I would like, I think what I'm going to do just to make sure that is actually working without having to do anything else, is just set dB to the pressure limit. Okay, and setting, have I got that the right way around? I always forget this syntax for this thing. So S, where are you? Whoops. And D, so yeah, set dB. It's the other way around. I always get that wrong. There you go. Okay, pressure limit. And confirm. And export. Everything's still green. So right now the pressure limit should be 100. No. Oh, because I'm writing it somewhere else, aren't I? Yeah. And someone did say, by the way, the memory I had there, I didn't necessarily need that memory for the regulators. I could have used the DB itself. I'm using the DB as the activate state, which is currently purge. And right now it is back to 0, but we know that code works. So I just need to scan through this just to look for any other DB lines, which is that one, the mode. And we can get rid of mode as well. We can test by the levers themselves, as someone did say. I just find it handy to have a mode that I can actually read somewhere. So let's just see. That's currently set to 300, which it shouldn't be. And it's set to 100. I've got that code the wrong way around, haven't I? So open, clearly open is the wrong way around. Open 1, I need to just change this around. So if is greater than 0, whoops, relative greater than 0, then that should work. Export 300, 100, hopefully. Yeah. Okay, so that just sets a pressure limit, and then I can then basically decide with this center section if I want high pressure or not. So in this case, I'm not going to have high pressure. And we're going to test just having this automatically process iron. So I'm going to dump this mold, and we're going to see what another commenter did say, that you can leave the mold open apparently and just process stuff. So let's activate it. And there it goes quite quickly. 100, yeah, stabilized. And I have a mining belt here, which has got iron in it. So let's see how well this does at this job. There we have, just iron. So let's activate this thing. Up it comes. Yep, it's building temperature. And if I just dump this through, let's see how quickly it takes to actually go through there by comparison to our arc furnace, which is already okay for something like iron. Did that just dump out, or was that just me? It probably did just dump out, which while I wasn't looking. So let's just see, are you going to process? There it goes. We'll produce, and come on. There it goes. So yeah, this is remarkably fast at processing ores, and I guess technically I could just keep dumping this in because it is just one ore. What you have to be careful of here, however, is if you combine this with an alloyable ore, and you don't, oh, see, there it goes, it's lost temperature already. So yeah, that is still processing stuff through, and it will dump ore out. If you're just going for one particular kind of metal, what you could do is just again use a sorter, and you could decide just to dump ingots one way and ores another way, and that would certainly couldn't solve the problem, although right now it is just dumping that out. It's already probably too low a temperature to actually process that. So there are some more options that we can do for that for later, but for now that is good. And if I just purge this, we should be pretty good. So that is going back into our system, and this is all working pretty much how I want it now. So yeah, I think everything there is done. That can get covered back up again. I could do with signs in here perhaps, but that's something else for later. And we're done. So yeah, I'm happy with the furnace program. I don't need anything else. That should be able to make any alloy I like now without any problems. That floor grating can go back. And until we get to the hot gas setup, that is done. So I hope you enjoyed today's episode. I know there's not been a lot done, but we've sorted out a few things that we can and can't do, that much is for certain. I would like a solution to be able to separate this reagent mix from that reagent mix. If anyone knows of anything other than, hey, they came out as two different balls, so then just shove them both into a furnace, do let me know. I'm more than interested to have them nicely separated into Invar and everything else. If I can't do that, then I can't do it, and I'll just have to heat it up to Invar, dump the stuff into the furnace, and reprocess it. It's not like we need to recycle all that often, is it? So I guess it's not too bad, but it is one of those things that I want to automate all the things. Whoops, all the things. There we go. All right, so we'll see you next episode, and I will get to the greenhouse at some point, I promise. It's just another thing that's just keep getting in the way when you want to automate everything. So if you like the episode, give it a thumbs up. We'll see you next time. Feel free to subscribe if you aren't already subscribed to the channel, and yeah, hopefully you enjoyed. As always, guys, thanks for watching.